Hello everyone, this is Mr. Underkoffler, and today we're looking at the guided notes called Subtracting Integers. I put a little asterisk next to the word integers. Integers just means whole numbers and their negative counterparts. That's what integers means. We talked about that before on a previous page of guided notes. Let's start with some vocabulary here. We have the word opposite. Now, opposite is obviously a real life word, but in mathematics, opposite is a simpler word for the official phrase called additive inverse. And what it means is that it just means the opposite sign of the number. All right, so the opposite of 35 is negative 35. The opposite of negative 2 is positive 2. All right, so that's what opposite means. But it's important you understand that because otherwise you're not going to understand the rest of these guided notes. I'm going to talk about that word opposite a lot over and over again on this page of guided notes. By the way, this is going to be part 1 of the video of this packet of guided notes on subtracting integers. We'll do a separate video for the second page of this same packet of guided notes. All right, here's the major rule you need to know. Subtraction problems, meaning problems that literally have a subtraction symbol in between. They are the exact same thing as having the problem written as adding the opposite, specifically the opposite of the second number. For example, 14 minus 22 is the exact same thing as 14 plus negative 22. They both equal negative 8. And you might have already known that. You might have remembered that I taught you that a smaller positive minus a bigger positive will end up as a negative answer, so negative 8. But you also learned that when you have a positive plus a negative, they're different signs. You find the difference, which means you subtract in your head, and then whichever number has the bigger absolute value, in this case it's the negative 22, will determine if the final answer is negative or positive. So that's why it's negative 8. So you already probably knew this. Both of those problems have the same answer of negative 8, which proves my original statement here, essentially proves what I'm talking about, that subtraction problems are the same problem, but written as adding the opposite of the second number. Remember how the second number used to be 22? Now I'm writing it as negative 22. Now, you might be like, Mr. Underkoffler, why in the world should I care? I will tell you exactly why you should care. It's because as your math teacher, I have to decide what's the easiest way to teach subtracting positive and negative numbers. And basically I have two choices. The first choice is to teach you a brand new set of rules. You might remember from the adding integers guided notes that at the top I kind of broke it down into two separate categories, a negative plus a negative, but also a negative plus a positive. And I kind of went over different rules, and there were like 2 parts to the rules for each. And so that was kind of like a total of 4 different things you had to memorize, so to speak. I could do that again with subtracting integers. The problem is the rules would get very complex, and they're very easy to get confused with the rules you just learned from the adding integers guided notes. And so I have learned that that would lead to mass confusion and a lot of kids being very unhappy because of how easy it is to get confused between the two rules. So the second option is the easier option, and that's what I'm going to choose to do on these guided notes. And that second option that I'm choosing to do is to teach you that you can transform, you can rewrite every single subtraction problem that has positives and negatives involved. You can rewrite them into addition symbol problems as long as you make it adding the opposite. You're like, well, why is that better? Because you already learned the rules of adding positives and negatives. So what I'm going to teach you is a simple trick you can do on every single subtraction problem that will allow you to use the same set of rules with addition of positives and negatives that you have already learned. To me, that's working smarter, not harder. You're only going to have to learn one trick, and then you'll do what you did before, instead of learning 6 brand new rules, which would be very confusing. So I'm trying to teach you in the quicker and easier way. You got to trust me on this. So here's what I'm saying. Follow along. If you choose to rewrite each subtraction problem as adding the opposite, then you will have less to memorize since you already learned how to do addition symbol problems with positive and negative integers. So that's the idea here. All right, we're going to take this piece by piece. The first page of the guided notes, we're not even going to get final answers. All we're going to do is what these directions say. We're going to rewrite each subtraction symbol problem, meaning problems that have literally minus in between, subtraction. We're going to rewrite them as adding the opposite. And when I say adding the opposite, I'm specifically talking about the opposite of the second number, like I said in the big box at the top of the page. However, keep reading. If it's not a subtraction problem, then we're going to do something very unique for only the first page. We're going to say, okay, well, we're not going to rewrite it, so don't rewrite it. The only problems that we're going to make adding the opposite are the subtraction symbol problems, because that's the rule of the day. Subtraction problems are the same as adding the opposite. Not addition problems, not multiplication problems, not division problems. Only subtraction problems are the same thing as adding the opposite. So that's the name of the game. We are not going to find the final answer. Don't do it. We're just going to rewrite each subtraction problem as adding the opposite. Now, I gave you a little helpful box here on the side. 3 things that you're basically going to do. When you make subtraction rewritten as adding the opposite, first thing, the number before the subtraction symbol, which means to the left of the subtraction symbol, will not change. Take a look at number 1. 9 is still 9. It did not change. The number before the subtraction symbol, the number to the left of the subtraction symbol will not change. Here's what will change. The subtraction symbol will become addition. So this subtraction symbol that I have highlighted in yellow on number 1, notice it becomes addition. But it doesn't we don't just do that. Take a look at this third arrow point here. We're going to change the second number to its opposite sign. So the 21 becomes negative 21. This is what we mean by adding the opposite. Subtraction becomes addition. The number to the right becomes its opposite. And believe it or not, even though the new looking problem looks different from the original, they're actually the same. They look different, but they have the same answer. And that's what I showed you here on the place where it said, for example, 14 minus 22 is the same as 14 plus negative 22. But again, the greater purpose of why we're doing this is because, believe it or not, this is going to give you less to memorize. Because after you do this cool little trick of making subtraction become adding the opposite, then you're going to have an addition symbol problem of positives and negatives, and you'll get to use the same rules that you just learned from the other packet of guided notes called adding integers. And that will make it easier for you in the end. You have to trust me on this. All right, take a look at number 2. The first number stays the same. Negative 14 is still negative 14. But what changes? The subtraction becomes addition. The negative 29 becomes its opposite, positive 29. And so that's how we rewrite the subtraction problem of negative 14 minus negative 29 to become adding the opposite, negative 14 plus positive 29. Again, the first number on the left, doesn't change. Only the one that was to the right of the minus, that's what becomes its opposite. Here's another example that's already typed up for you. Negative 32 minus 48. The negative 32 stays the same. Get the moral of the story here? First number stays the same. Subtraction becomes addition. And then the number that was to the right of it, which was 48, becomes its opposite, negative 48. Now, number 4. Why did I not make it adding the opposite? Why did I instead say I'm not going to rewrite it? Don't rewrite it. Why am I doing that? Well, would you please hit pause on your video, and where it says follow up to number 4, and it says why should you not rewrite number 4 as adding the opposite, please take a minute, write the reason why we did not make number 4 become adding the opposite. Hit pause, do that now. All right, I hope you already answered this follow-up question to number 4. Why did we not make number 4 become adding the opposite? It's because, did you notice there's not minus in between the numbers? It's an addition problem already. What did our guided note say at the top? It said that subtraction problems are the same as adding the opposite. It didn't say addition problems are the same as adding the opposite, and this is an addition problem, isn't it? So, you should have somehow explained this in your own words. The original problem was not a subtraction problem. Only subtraction problems should become adding the opposite, because only subtraction problems are the same as adding the opposite, not addition symbol problems. Moral of the story, don't ever rewrite addition symbol problems. In fact, I'll go even further. Don't rewrite multiplication problems. Don't rewrite division problems. The only problems that we are rewriting are subtraction problems to become adding the opposite. And number 4 did not have a subtraction symbol in between. It had addition. The only ones that we are rewriting today to adding the opposite are the ones that have subtraction in between. All right, I hope I've clarified that. Let's do some of these problems together. Let's do numbers 5 through, let's do 5 to 9 together. All right, here we go. Problem number 5. First number is 18, then we have minus 27. Do we change the first number? No. So everybody write this down. 18 stays 18. Bring it down. Subtraction. What does it become? It becomes addition. What about the number that was to the right of it? We'll follow the rule of the day. Subtraction is the same as adding the opposite. What's the opposite of 27? Negative 27. If you want to put that in parentheses, you may, but you don't have to. By the way, you don't have to draw the arrows. I'm trying to draw the arrows only to make it crystal clear visually for you how I made the subtraction become addition, and the number to the right of it, its opposite. All right, let's do number 6. Do I change the negative 46? Nope. The little box at the top tells you, well, not at the top, but the little box here next to 1, 2, and 3, and 4 tells you you're not going to change the first number. When I say first number, I mean the one on the left. So negative 46 stays. Do not make it positive. It stays the way it is. The subtraction becomes addition. Now, what about the 99? This used to be regular 99, right? Don't think it's negative 99. This dash was the minus. I already made that minus become addition, okay? But this 99 has to become its opposite. The opposite of 99 is negative 99. So make sure that is what you did for problem number 6. Okay, number 7. Will the 4 change? Nope. First number never changes. Keep it the same. What happens to the minus? Becomes addition. What happens to the negative 61? Well, did you follow the rule of the day? Subtraction is the same as adding the opposite. What's the opposite of negative 61? Positive 61. For today, I would actually show that you're making it a positive. I'd actually draw that little tiny plus symbol, positive, just to visually show you that you indeed made a change from the negative 61 to a positive 61. Yes, I know, plain old 61 is the same as putting a positive symbol next to the 61, I know. But I'm going to go ahead and recommend you put the positive symbol. Okay, number 8. Negative 15 stays the same. We always keep the first number the same. The subtraction becomes addition. I hope you guys are writing all this down. I'm not doing this for me. I'm doing it for you. Make sure you're writing it down. Negative 9 becomes its opposite. The opposite of a negative is a positive. Again, if you didn't hear me say it before in the video, you do not have to draw the arrows. This is what we should have. If you were sitting in my classroom right now, I would ask you to talk to your neighbor about why number 9 is different from numbers 5, 6, 7, and 8. There's something uniquely different about it. Do you see what I see? I'm not singing a holiday song to you. I'm literally wondering, do you see what I see on number 9? Something is very different. This is not minus. There is a plus sign in between. Is it correct to say that addition problems are the same as adding the opposite? No way. The rule of the day, the big rule I'm trying to get you to learn, is that only subtraction problems, problems that originally have subtraction between the numbers, they're the only kind of problems that are the same as adding the opposite. They're the only ones. So, what did the directions say to do if the problem is not subtraction? It said to write the phrase, don't rewrite it. So, that is what we're going to do on number 9. We're not going to rewrite it because it was not a subtraction symbol problem. It was an addition symbol problem. I hope that makes sense. All right, time for you to do some on your own. Would you please hit pause on the video and do 10, 11, 12, and 13 on your own? Hit pause, do those 4 problems. All right, I hope you did that. I hope you hit pause on the video and already did 10, 11, 12, and 13 on your own, because now I need you to get your pencils and erasers ready. Make sure every single part of it is perfect. Details matter. One negative sign missing that shouldn't be missing would totally change the meaning of the problem. So here we go, problem number 10. Negative 30 stays negative 30. Do not ever change the number that is written first to the left of the minus. Don't do it. Keep it the same. The minus should become adding. The second number to the right of the minus will become its opposite, so that becomes positive 34. Double check, make sure that's what you have. Number 11, did you see what I saw? This is not a subtraction symbol problem. It's addition, so don't you dare change it. Don't rewrite it. Just like the direction said, don't rewrite it. All right, problem number 12. The negative 102 stays negative 102. The subtraction becomes addition, and the 87 becomes its opposite. I hope you realize this number to the right of the minus. Sometimes this is hard for kids to see because they see the minus and they accidentally think that that 87 was already negative. The original 87 was just positive 87. So when I say add the opposite, that's why it becomes negative 87, because the opposite of 87 is negative 87. Hopefully you already understood that. All right, number 13, the one that should be, I think, to the right of your number 12. I kind of ran out of room. To make this big enough on the screen for you to be able to see, I had to squeeze my number 13 underneath my number 12. All right, shouldn't be a big deal. 54 stays 54. Don't ever change the first number. Subtraction becomes addition. The next number becomes its opposite. What was the number to the right of the minus? Well, it used to be a positive 239. So the opposite of a positive is a negative, and that's why it is 54 plus negative 239. Again, you don't have to draw the arrows. I just like to do it so that way, hopefully, as you're watching the video, you can crystal clear see what exactly I changed from the original problem to where I write it as adding the opposite. Okay, we are almost done with this first page, but now I'm going to make it a little bit more interesting for you. I'm going to show you problems that have 3 numbers involved, and I did something tricky. Take a look at this. Number 14, I have plus, but then I have minus. Do you realize that the rule of the day says that only subtraction becomes adding the opposite? Addition does not. Addition does not change. Now, I'm not going to write the phrase don't rewrite it, only because there was a subtraction part to the problem. And that subtracting of 13 did indeed become adding the opposite, didn't it? Adding negative 13. But the 6 plus negative 8, it doesn't change because it wasn't minus. It was 6 plus negative 8, so it stays 6 plus negative 8. Remember the rule of the day. Only subtraction is the same as adding the opposite. Not addition problems, not multiplication problems, not division problems. Only subtraction problems are the same as adding the opposite. So that's what makes this a little trickier. Now take a look at 15. This was subtraction here, isn't it? What I'm highlighting in yellow, subtracting 70. So that becomes adding the opposite, adding negative 70. But this problem is unique. The second part is also subtracting. So that also becomes adding the opposite. which the opposite of a negative 36 is positive 36. So 15 was unique because there was subtraction of 70 and then also subtracting of negative 36. Two parts had subtracting. Don't forget, negative 25 stays negative 25. The first number always stays the same. Same thing on over here, 6 to 8 is 6. Don't forget, first number always stays the same. But number 15 was like double for our trouble. We made this subtracting highlighted in yellow become adding the opposite, and we made this other subtraction part highlighted in green also become adding the opposite. If there's subtraction at two different places, you must make both places become adding the opposite individually. But in number 14, if there's only subtraction at one place, then that's the only place you make it adding the opposite. The addition symbol part will stay the same. I hope I've made this crystal clear as to how you're going to do this. Okay, 16, 17. I want you to do them on your own. Hit pause on the video, do 16 and 17 completely on your own. Okay, I hope you did that. I hope you hit pause and already did 16 and 17 on your own. Let's see how you did. Here we go. Number 16. It only had one place where it was subtraction, and I just highlighted it for you. So that part should become adding the opposite. Let's see how you did. Did you keep 7 as 7? You should have. Subtracting of 11 should become adding negative 11. Because of the rule of the day, subtraction is the same as adding the opposite. But the next part is not subtraction. The next part is addition of 29. That should stay the way it was. Never, ever, ever rewrite addition symbol problems into adding the opposite. It's wrong. Don't do it. It will not work. All right, problem number 17. Where do we have subtraction? Well, I hope you realize the first number does not mean subtraction. The first number is just negative 3. First number always stays the way it is. You should know this by now. Here we have subtracting of negative 5. Subtraction is the same as adding the opposite. You have heard me say that rule over and over again, haven't you? You're probably tired of hearing me say it. So did you make that become adding positive 5? And then we have, what's next? Another subtraction piece. Subtracting negative, subtracting 17. That needs to also become adding the opposite. The opposite of 17 is negative 17. And that is the last problem on the first page of the guided notes. And that's where I'm going to stop this video. We'll do the second page separately in a different video. Thanks for watching. We'll see you next time.